I hope this is the right one.
All right, if you guys would please download the 2 folders in today's date on the Teams drive, GIS data and more GIS data.
Or is this the book we're supposed to get?
Yeah, that works fine.
Okay.
The 7th edition and the 8th edition didn't change very much.
I could send you the link to it if you want to send it up to the class.
Sure, yeah, please do. Nothing completely illegal about that.
I need to go and just organize it.
Yeah.
I don't know what I Okay, so last class we talked about projections and coordinate systems. We're going to go into a little more depth with that today, and we're also going to use another tool in our toolbox to actually process our data. But this time I gave you an actual step-by-step guide, and we're going to try and follow this closely. So if you would please very carefully pay attention when I say bring in this file, bring in that specific file in the order I tell you to do it. And if I tell you to start a new instance or bring in a new data frame, it's because we're trying to create an entirely new coordinate system in that data frame. So don't get too far ahead of me unless you're following this very specifically, or don't get far behind me because you'll get lost. And if you get far behind me, please, please, please raise your hand. I promise I won't make fun of you. Neither will Tyler, right, Tyler? All right, go ahead and open a new blank instance of ArcMap. And I would like for you to bring in from GIS data, the files lat/lon first. Give that a second to load. You can actually make that hollow because we're going to look at these latitude and longitude lines. This is a projection that you're used to looking at world maps in, the Mercator projection. Bring in the file called circles. You can put that on top of lat/long, make those red and hollow so we can see those. And the last file I'd like you to bring in is this one called World Cities from the GIS data folder. It doesn't look like a shapefile. It's got this little yellow diamond. This is a layer file. We'll talk more about layer files, but for now, I would like for you to bring that in. We'll take a look at what a layer file is and what the difference is between layer files and shape files. It's gonna come in with a red exclamation mark. And the last file I'd like you to bring in is the world countries file from GIS data. And you can put that under the world cities. If you put circles on top, we want to watch these circles.
So we don't want the dot layer file.
We do want the dot. We want the file that looks like a little yellow diamond here, worldcities.lyr. And it's going to come in with the red exclamation mark. I'll talk you through that in just a second.
No, mine's green. That's not right. Sorry. I feel very like that's not right. It's green with this. Oh.
Yeah, I had to go on it. Yeah, this
So
one.
I want to know, how did you get your circles hollow?
Better.
Did I miss it?
Did you already separate those? Did you already separate those cities out? The red?
Yeah.
You already did that a step ahead?
Yeah.
Okay, you're fine. I just wanted to make sure. You're going to run into that's fine. Use that, but that world countries file. By the end of class, this will make more sense, but I'm just gonna tell you right now, I dissolved that into this because that is an astronomical file. So uncheck it at every chance you get, okay? So all we wanna do is look at it periodically. So the reason I have this one instead of that one is to eliminate a lot of that data.
I'm just curious, if you re-downloaded it, would it be better? You know what I mean? If you just
It's
re-downloaded
probably
it.
gonna go, you'll be okay, it's just gonna take a little while. You brought in. That's okay.
Okay, no problem.
You want this one, looks like that little yellow diamond. And you want it to have the red exclamation.
Oh, that makes sense.
So that they're fine. We want it to be visible. Yes. I'm just doing this because we want to see this and has it changes. We want it to be very clear.
I'm gonna make
You
my
heard what I said about that file being huge, uncheck it at every turn.
Oh, look at mine.
All we want to do is look at how it changes, but that file, you'll know what dissolve means by the end of class. That is the file.
There was 2 files.
Is there another question?
Yeah.
It's in one of them.
You're good? All right. Okay.
Actually, do I need to pull in the world country from some other folder because I don't see how to.
See, he doesn't see it.
Yours is the same thing as his though? You don't have world counties?
If I re-downloading, just go to the team.
Yeah.
Like if I filter here and look
Yeah,
at
one.
Well, you're copying it.
like world
It wasn't,
country,
it was in like
copy that.
Monday's folder and not today's folder.
Did you hear that?
That's right. That's right.
Where did you find this circle spot?
Hey, you two, try the 2.1 folder. For some reason, apparently Teams put it in 2.1. I don't know how I got it in 2.4, but. Yep, it's in there. This is a folder we're going to use today. I don't know why Teams separated it into 2 different dates. So if you would please go ahead and download this folder as well. I don't know what's going on here. So this folder 2.1/2021, download GIS data.
So it was.
I have no idea why. I must have somehow separated them when I drug it into Teams.
So get rid of that.
Say that again?
So he just said that he did last
Yeah.
week.
Mine up online.
Yes, okay. So you guys, a couple of people have looked it up online. I really should update these, but we're gonna have to get rid of them soon. This picture, this graphic is from the original file. This won't mean anything to you right now, but the file we're looking at here is, I promise, the same file, but it's been dissolved in order to make this work faster because this file is huge. So I took out everything inside the country borders. We're gonna do that by the end of class, but I just did this and gave this to you because this file is so big to work with. It takes forever. Every time we click it on and off, redraws. So for now, just bear with me. I promise this will make sense. It's been dissolved. We'll continue to use the one I gave you instead of the one that it looks like on the paper. Okay. So let's see. Oh, next step, please bring in the state of Montana. Just montana.shape. And you're going to get this warning that you should be familiar with. Just close it for now. All right, the first thing we want to do is link this layer file to the shape file. The only difference between a shape file and a layer file is that the layer file tells you how you want to view the shape file. You set it up like we did the roads and the freeways and whatnot, and put all these different styles on them and put labels on them. If we had saved that as a layer, every time you opened that layer, it would come in exactly that same way. So what this has done is it's categorized this for us Now we just need to tell it which shapefile it's in. I specifically put that in a different folder so that you could see how this works, but right click, data repair data source, and in the more GIS data folder, you should have world cities shapefile. And when you add that, your world cities will come in and display the way they should. That layer file is just a way of viewing your shapefile. And if the two don't stay together, the layer file gets confused as to what it's supposed to be displaying. It knows how to display it, but doesn't know what to display. All right, from last class, what's wrong with the state of Montana? Feel free to zoom in on that layer and tell me what's wrong with the state of Montana. Also from your homework. It's all flat and it's all stretched out. It doesn't look right. What does that tell us about how we're viewing it? It's not projected. We are looking at it in Mercator, which is a world view, and Montana is too far to the north for a world view to display the area accurately. What coordinate system are we viewing it in? I actually don't know, I'm asking you, but yes, WGS 84. Everybody see where he got that from? The very first file we brought in was the latitude longitude file, and it was in WGS 84, so we assigned, by bringing that in first, the data frame to be in WGS 84. That is a world coordinate system in the Mercator projection, so it doesn't work well for Montana. So we're going to come back to this throughout this tutorial, but for now, I would like you to scroll back out to the entire globe, noticing that everything north and south of the equator is skewed a little bit, stretched out wide in the Mercator projection. And we're going to take a look at distances between a couple of points.
Did you say WGS 1984?
Yep.
Okay, that's, and it just applied.
It should be in WGS 84, so it should have been in WGS 84. So it's like it was. Or in URS. So is it okay? Yep, you're good. So that it should have been there and you didn't change anything, you just leave it there. All right, so what I want to do is only view the cities that are larger than, what is it, 5 million? Yeah, the largest cities. There are 36 of them. So let's get rid of everything but those 36. How would you do that?
Can we do it by open attribute table? Or would you rather do it by properties and symbology?
Properties and symbology is what I'm going for. You can do open attribute table, but we aren't there yet in this class. So we'll talk about that later. Under properties, symbology, we don't want to see any of these. So just remove. And then we should only see the cities highlighted in red.
You zoom in, their names are still there, those guys.
Yep. Because we have not gotten rid of them, we haven't turned off the labels. So we're not going to worry about that right now, because what we're going to go for is only Tokyo and New York. So I'm going to have you use the select features tool. Under selection, go down to interactive selection method. In the past, when we've used our selection tool, if you click on something, it highlights that item. If you click on another item, it erases your previous selection and creates a new one. In this case, I want to select only the cities. I don't want to grab all this other stuff. So I'm going to tell my world cities, right click, selection, make this the only selectable layer. Now remember, you have that set, because if you try and select something else later, it's not going to let you do that because you set cities to be the only selectable layer in this map. But what I want to do is select only New York and Tokyo, but I want to grab them both. I don't want it to create a new selection. So go up to the top, selection, interactive selection method, add to current selection. Now, if I choose New York and Tokyo, it's going to highlight both of those. It probably picked up a whole lot more than New York and Tokyo because although I don't see the other cities on this map, they haven't gone anywhere. They're still there. So my clicker is way too big to be as specific as New York and Tokyo. So I'm going to open my attribute table and see what other cities I accidentally grabbed. Get rid of those.
What's the other toolbar?
Tools toolbar, customize tools, customize toolbars, tools toolbar. Okay. Yep. Okay. So I can see when I open my attribute table, I've selected 7 cities. So the possible 2,540 that are over 5 million. I don't know which those are. I could scroll through this list, but that's gonna take a while because that's a lot of cities to scroll through. I can also just go to my selected records by using this button here at the bottom and only see the 7 I've selected. New York and Tokyo are in that list. I want to remove everything except those 2. So what I'm going to do when I'm in this menu is I can highlight from the selected features by clicking on these. If you hold your control button down, you can highlight everything except New York and Tokyo. You okay? Once you have those highlighted, you have these little features that pop up at the top. Unselect highlighted, reselect highlighted, and zoom to highlighted. I only want New York and Tokyo. So what I'm going to do is unselect the highlighted towns. That limits me back to just selecting New York and Tokyo. And if I close my attribute table, see those are the only 2 selected. And I didn't pick up all the other cities around them. Export those as a new layer. We want only New York and Tokyo on our map. Don't forget to save it as the type shapefile. And we do want to add it to our map. We can now uncheck world cities because all we're really interested in is New York and Tokyo, and blow them up so that they're visible. We want to see those 2. They're far enough away from each other on the globe that we can actually see some of those distance measurements we talked about last class impacted by the coordinate system we're working in and the projection we're working in. If your computer is being really slow on you and it's giving you a hard time, you can uncheck world countries because right now we don't need to see the countries, we just need to see the cities. Anytime your computer starts slowing down on you, you can uncheck that just for the time being because every time we do something, it tries to redraw that, and that's the biggest file in here. So if it gets slow on you, just uncheck that.
How did you get rid of the yellow highlighted fields?
I went to, when I had something selected, you go into your selected folder, and then when you click on it and highlight one, you get these tools up here. Yeah. This first one is unselect highlighted, so if you click on that, it's going to remove anything that you have highlighted. It's going to unselect it from your selection. All right, we know we're in WGS 1984 right now. Let's go ahead and rename that layer to WGS 1984 so we know what we're working in. Now I'd like to measure between these 2 cities in the 4 different types of measurements we have, but I'd like to measure it in miles. So go ahead and first set your distance, or your distance to miles. Mine was in feet. we can't measure in planar because we're in an unprojected system right now. So our only options are a geodetic, loxadrome, and great elliptic. Let's look at those three measurements. Start with geodesic, make sure it's selected. Use your line measurement tool and go from one city to the next. And you can double click to drop that point. Single click to just hold it there. Any guesses on why we're getting this arc that disappears off our page? Shot in the dark? Thinking maybe of the planet as a sphere instead of a two-dimensional rectangle? The shortest distance.
Bring background the other way.
Yes, exactly. The shortest distance between New York and Tokyo is on the back side of the globe from the view that we're looking at it in. Exactly. Geodesic, remember, treats the planet as a sphere, and the shortest distance between those 2 points is wrapping around the back side of the globe in the version that we're looking at here. Double click to get rid of that, or you can use your little X to get rid of that, and go down to the Loxadrome measurement. Actually, I'm sorry, I forgot to write down what the measurement was. Measurement is 6,756 miles. So clear that out and try Loxadrome. $7,964 miles. Anybody remember why Loxadrome is longer than geodetic?
Because it's taking what would look like a straight line on a Mercator projection map, but in reality it's an arc.
Yes, precisely, because they're actually following a direction. And to do that, it creates an arc, and they actually follow more of a jagged line, and it makes that longer. So if you're flying an airplane and you need to know how much fuel to put in your plane, you need to measure in the correct coordinate system, basically. You can overdo it with Loxadrome, or you could actually measure in geodesic. Now, great elliptic should be very, very similar. We might be a little bit off. Let's try great elliptic and see how close it is to geodesic. Oh, it's off in decimal places. I think the geodesic was 6,756.29. Remember, the great elliptic treats the world less like a sphere and more like an egg. It's kind of elongated. It's like an oval instead of a sphere. So it adds a little bit of distance, but not much. Okay, so you can close that out for now. Get out of the measure tool. Figure out where I'm supposed to be next. I'm trying to follow this carefully, but I don't have it memorized, so I just got to figure out where we want to be on the next step. Okay, well, one more thing to notice. I'm going to turn the world countries back on. On the measure tool, remember, when we are not in a projected coordinate system, we can't measure an area. If we wanted to measure an area of, say, these circles, we'd have to put this in a projection. So I'm going to get back out. I'm actually going to leave these up now so we can watch how they change when we change the coordinate systems. This is an unprojected Mercator coordinate system. Let's put this in an actual projection. Actually, let's do another one that's not WGS first. Let's go into another really common one that falls on the Mercator projection that you're going to see all the time is the NAD 1983, Geographic Coordinate System NAD 1983. Now remember, your coordinate system is just the numerical system that we apply projections to in order to look at them. So when we see state plane NAD 1983, state plane is the projection, NAD 83 is the coordinate system. So let's look at the coordinate system NAD 1983 without a projection. Open up Geographic Coordinate Systems, scroll down to North America. USA and territories, and just choose plane NAD 1983. You're going to get this warning because we have different coordinate systems in the map. All this did was shift it a little bit because we're still in the Mercator projection, but the coordinates are just a little bit off between NAD 1983 and WGS 1984. I think they're off by about 2 centimeters or something crazy like that. It's a very, very small shift, but WGS 1984 is kind of an old system. NAD 1983 is a little more correct. So let's put this in a projected world coordinate system. We're going to look at the world in a semi-conical projection. Let's put this in Robinson world. So we want to get out of geographic coordinate systems and go into projections, projected coordinate systems. Scroll down to world, and near the bottom we should have Robinson world. And say apply. Robinson and Winkle triple are the two that you're most likely to see in this, they call it aesthetically pleasing projection. This does not accurately represent anything, but it is one of the most common ways of viewing the world where it doesn't significantly warp the area or significantly warp the distance. So it's kind of a compromise between a true projection of a small area and actually looking at the entire globe. But let's use the Robinson and actually measure between these 2 points again. And I should change this to Robinson since we're talking about a different coordinate system. But again, measure that in miles. This time, because we're in a projection, we have the option of doing planar. And remember, the difference between planar and these others is that planar assumes a flat surface across the globe and a straight line between those two across a flat surface. So in planar, this is our largest measurement so far, 11,730 miles. Pretty different from the previous measurement in the Mercator, which was 6,700 something.
Well, isn't that because the line is not going around the Pacific now?
Yes.
So
And that is part of the trick of which projection you use and how you measure it. Good catch. That's awesome. So try the other measurements as well. And look at the difference. The geodesic measurement. Come on.
So if it won't let you pick a different one, like you just.
Double click just on an open space in the map so it'll clear out the line. It doesn't like to do it when you've got a line there. As Gabe pointed out, the geodesic wraps around the backside of the globe because they're actually looking at the shortest distance between those 2 points on a sphere. A planar assumes it is not a sphere, it's a flat surface. Does that make sense to everybody? Okay, really important to get your measurements correct. Loxadrome. My computer's freezing up on me. $7,940. But again, Loxadrome follows that direction and it goes around the backside of the globe because this is not a flat surface, it's a spherical object and it's looking for the shortest distance. And great elliptic should be very similar to geodesic. All right, while we've got this up, because we're actually in a projection now, albeit a world projection, we can measure areas. So keep in mind, when I put these circles on here, they were perfectly spherical, but I put them on in Mercator. So they were already warped from being true circles simply by being in Mercator. But this tool in your measurement allows you to measure a feature Allows you to pick a feature in your map, a shapefile feature, and measure the area. Choose that tool, that little measure in area, and select one of these circles. If it will let you. Okay, area measurement. 519 miles. Oh, 0 square miles. No, that's, damn it. Why aren't you measuring this? I'm gonna uncheck everything else because it's being grumpy with me. Why aren't you measuring the circle? Okay, I don't know why it's not measuring the circles properly.
Did you click on make only this selection layer selectable on the circles?
This isn't a,
That was my issue when I fixed it.
oh, did it? Well, this isn't a selection, so that should not apply here. Huh, that does seem to work. Oh, no, still not doing it. Nope, still not working. Well, we'll come back to that. Actually, I've already done the measurement for you. I was going to have you actually look at how that works, but open the attribute table on circles, and this column Robinson is the area measurement of each of these circles. You can select each one and see which one it is, but notice none of the circles are the same area because we've changed the distortion from the Mercator. We could have looked at it in WGS, but because WGS is unprojected, we can't measure an area. It wouldn't allow the measurement of the area to occur on the circles. Okay, I'm going to close my attribute table. I'm going to turn my world country, well, I'm going to turn Montana back on because what I'm really interested in here is in the Robinson projection where we have we're looking at a world projection, but we have semi-modified everything for area and distance. This is what Montana looks like. Another really weird one. Montana does not look correct in this world projection. So let's go into one that actually looks correct for Montana. You can zoom to layer on Montana to watch this transformation. Let's go into state plane international feet. So change your data frame properties, projected coordinate systems, expand state plane, NAD 1983 international feet, and choose the Montana FIPS 2500. This is one I showed you last class. This one and Universal Transverse Mercator, or UTM, are the two most common projections for small areas in the United States. And say, yes, we can ignore that. Now that's what Montana's supposed to look like. That's an accurate depiction of Montana, but let's turn the world countries back on and zoom to layer on the world countries and see what the rest of the world looks like if we're focused on Montana. The only thing correct in this map is Montana. Everything else is heavily distorted. Look at South America. Australia is almost the size of Africa. Everything else is severely distorted when we're looking at Montana. But Montana's correct. No matter what you're doing, something's going to be incorrect. So you choose your projection based on the most correct projection for the area you're looking at. If you're looking at the world, Robinson, Winkle Triple, there's a whole bunch of others. If you're looking at Montana, UTM state plane. So whatever area you're looking at is the most accurate. Now look at these circles and see what's happened to the circles. Open up the circles attribute table again and take a look at how these changed. And look at the areas. One of the circles is completely missing because it was so close to the pole, it just zeroed out. Has no area. Now try those measurements between those four cities again. And look at how they differ.
I don't know if this is a good question.
There's no
what
stupid
are the circles anyway?
They are completely made up.
Okay,
I just put them on there to show you how the maps distort.
okay.
It's not always, unless you have a really good idea of what a country looks like, it's not as apparent by looking at the countries. Mhm. All right, once you've got those 4 measurements, we're gonna completely start over. New fresh map. We wanna get rid of this because we don't wanna fool around with the projections. So go ahead and hit new, this little blank map, and say, yes, I want a new blank map. We don't need to save that map. That was just for looking at how things are distorted on a world scale. We are, by the end of this tutorial, going to create that map or something very similar to it. So this time, please bring in the United States shapefile. I would like for you to get rid of Alaska, Hawaii, and anything that's not, I think Puerto Rico is probably on there, anything that's not part of the continental United States. Create a new shapefile that's just the continental United States. Everybody okay with doing that? When you get that done, please add 2 new data frames to your map. And just like last class, I'd like you to go into layout mode and expand those data frames to be exactly the same size.
Where's the out in the frame thing?
Insert data frame.
When you had the attribute tables,
So what you want to do, the easiest thing, honestly, is drag a box around the continental US. And then open the attribute table, and there's a column that says what type of district or whatnot. See if it's got state, there are islands, there are a whole bunch of other options. If you have anything selected that's not a state or DC, unselect that from your list, and then you'll have only the United States that's continental.
so I just selected the United States.
So I have Alaska and Hawaii selected. Just went through.
Okay, so go into your attribute table, and now you want to switch your selection. So there's a tool up there that lets you swap your selections. Try that. So now Alaska and Hawaii are unselected. If you export that, they will not come.
Oh, so export data.
But we want to do it from the map or creating, just like, exporting Gallatin County into the county. Just exporting these.
Oh.
He's coming to help you.
Yeah.
there's like a huge scratch there. So go back up to where heavy record, yeah, the county separated from all of the. You exported the county?
Yes. Oh, just right here like this?
Exactly.
Okay.
Like a-
I see.
That happens.
Thanks.
Okay. Okay. You're shocked. Okay, so remember when you're in data view, you only see one. Okay, you guys don't have to do this. I'm going to put mine in layout mode so it's big on the screen, but however you do this is fine. I'm sorry, not layout mode, in landscape mode.
Oh, mine keeps getting smaller. Oh, maybe zoom. There we go. Right click on the side. Yeah, and zoom there.
You can actually remove once you've done that result, or once you've done that selection and you only have the continental US, you can get rid of the other US. We don't need that anymore. We're going to stick with this one from now on.
Yes, then I clicked again right after, and then I did zoom there again. I just kept doing it. There we go.
There we go.
You all set? All right, name these layers. The first layer that you've been working in, make sure this is correct, but look at your data frame properties and make sure it's in WGS. And if it is, name it WGS 84. Name the next one UTM 12 North, and the next one SP NAD 83. We have 3 data frames with 3 different names, and we're going to grab the 3 corresponding files to fill those out. And you can go back to data view, but remember, whichever data frame you have in bold or activated is the one you're going to be looking at in data view. So if you don't have anything in your active data frame, your data is going to be blank. So don't worry if your map is gone all of a sudden. You have, just look and see if one of your empty data frames is activated.
You're right. Yeah, sure.
Oh, no, no.
I have 3 files called Continental Dissolve here. State plane NAD 83 should go in the state plane NAD 83 data frame, SP NAD 83. UTM 12 North should go in the UTM 12 North data frame.
Yes.
And WGS should go in that first data frame. Respond well to commands. Shut up.
Thank you.
Yeah.
See how that was?
You can uncheck the continental US. We're going to come back to that one, but for now we're going to stick with these dissolved ones. If you could make these a hollow and make a bold color on them, whatever color works for you is fine with me. I think I said red, blue, and black in the tutorial, but I really don't care what colors you use, just make them different. You've got your 3 data frames in the same size. Okay. So open up the drive that we've got the shadows. SP NAT 83 goes to SP NAT 83.
Okay.
Got it?
That's so weird.
Run it in there.
And 12 more, and 12 more data frame. Bringing the dissolve, so we can set for the first one. We're just going to use the dissolve. We're going to come back to that, so the continental US, so don't get rid of it. Just okay. Now make all 3 of them hollow with different colored outlines, so we can look at them. And you can uncheck the continental US for now. We'll come back to it.
Yeah. Before I added.
Okay, bouncing between data frames, we can see they're all in there. I'm going to activate each one in layout in a data view. You can see they're all in there and they all look different. Back in layout view, this is what they should look like all together. WGS 84 is a world view in the Mercator projection, so the US is all stretched out and flattened. And we have, in red and blue on my map, 2 different coordinate systems specific to Montana that are just slightly different from each other because one is the entire state and one is a line through the middle of the state. So they look just a little bit different. Now what I'd like you to do is take your continental dissolved NAD 1983 and drag, actually let's take the UTM 12 North and drag it into state plane NAD 83 and take your continental dissolved WGS 1984 and drag it into state plane NAD 83. You're going to get this warning again, just ignore it. And let's go to the data view of state plane NAD 83 so you can activate that data frame. What I want you to see here is, you know that each of those files is in a different coordinate system. You know one's in WGS 1984, you know one's in UTM zone 12 North, you know one's in NAD state plane 83. But when we put them all in the NAD state plane 83 data frame, they overlap. Because we are seeing them in NAD 1983. It doesn't matter what our data is actually in, this is how we're seeing them. This is on the fly projection. Okay, does that make sense? So you know for a fact that they're different coordinate systems, but we're seeing them as one. This is why it's really important you pay attention to what coordinate system you're actually working in, as opposed to what your data frame is in. Best practice is always to keep all of your files in the same coordinate system. How would we do that? How would we take these two and put them in NAD83? If we wanted everything in NAD83.
We just right click on that.
Nope. Our toolbox is going to become your best friend by the end of the semester. Anybody remember this? What we want to do to take the coordinate system from WGS 84 or UTM 12 North and put it into NAD 83 is project it. Because what we want it to do is calculate. We know what the coordinates are and where it's located in WGS 84. Now we want it to calculate new coordinates in NAD 1983. So we have to tell it to project, create new coordinates, change where this is located. Tell me what it looks like in NAD 1983. So to do that, our toolbox, data management tools, projections and transformations, project. And we want to take WGS NAD 84 or UTM 12 North, select that. It's going to automatically read that as your input file and say it is in WGS 1984, which was our second green dot saying we have to fill that out, but it read that coordinate system. Now you don't have to put this in a different location, but if you don't, it's going to go to your default geodatabase, so tell it where you want it to go. And our output coordinate system is projected coordinates, state plane, NAD 1983, international feet, Montana. Now I want to point this out because I've seen a bunch of you guys doing it. When you select that, you shouldn't get another screen. You should just select that and see it. If you double click on that, you're going to get this other screen. It thinks you want to modify that coordinate system when you get this screen. It doesn't understand that you're trying to click that as a selection. It thinks you're going to go modify that a little bit. You don't ever want to modify the coordinate system. So if you get that screen, just say cancel, go back and just individually single select that one and say okay. And when you're ready, you can run that tool. We went from WGS 84, or I went from WGS 84 to NAD 1983 state plane. And when that's done running, I should get a little pop-up in the bottom with the green check mark that says this tool is projected. Green check mark means it's worked. Red X means it didn't. Yellow triangle with an exclamation mark means that there's a warning. It ran the tool, but there's something in there that was hinky, and it wants you to be aware that there may be an error.
Oh, right about.
Is that the Montana state plan or was it
That
that?
one, so-
That was Montana state plane. So I'm going to point out here, under properties for WGS 1984, the coordinates are in latitude and longitude, and this is the extent of that file. This is the file I started with before I projected it. My coordinates are in decimal degrees, latitude, longitude. Okay, this is the file I just projected to create. From this file, what it did was it changed the coordinate system into state plane feet. These are now the coordinates because this is projected into state plane feet. So the exact same file, different coordinates, same location, project, okay?
constant showing up there.
Uh-oh. Toolbox is doing it for you?
I have this and it doesn't fold down. I have this floor
You can use,
toolboxes and I don't know.
these are all the same thing. So you can do it here or you can, I've been doing that one. You don't have to do it that way. You can do it down here. This is the, an extension of our catalog.
So if I'm
That's personal
being
preference.
I'm being a little bit dumb. I can't remember where.
Data management tools.
Trying raster.
And we'll do raster next. Remember, this is a shapefile, so we've got to use the shapefile tools.
Yeah.
Oh, so you're going to data management tools. You're in the toolbox just fine.
Yeah, it's about.
And then projections and transformations.
You know how she gets her senseless, I don't get to know that, how do I?
So your toolbox is
So
fine.
she's like, "Hi,
You have another toolbox
Yeah,
at the
I
bottom.
don't
Of,
know.
if you scroll down through the bottom of your
Well,
table
that was
content,
good,
some people
yeah.
prefer that one. I like this floating one because then it's separate from the catalog.
Oh, shit, how do you think that?
Should be open up.
It's gone.
You
You
exit out of this catalog.
Probably.
Do you want to take those?
Oh,
every
wait,
time?
look at that. I got it.
Oh,
Yeah,
no.
In WGS 1984, decimal
So,
point
I are so lost.
39.
I don't do that.
So you stay in the exact same place. Just drag and
Oh,
recalculate
wow.
the coordinates.
Why so dumb?
So like, look on it, you see like the arrows that pop up once in the middle.
Yeah.
Place it on that arrow. Not the middle one, but
Yeah, it doesn't do that.
Oh,
Okay. You guys can get rid of, delete, right-click, remove WGS 1984 and right-click, remove UTM 12 North. But let's keep State Plane NAT 83 and you can remove the 3 files that are in that. We want to stay in State Plane NAT 83, but we want to bring Montana in. That Montana file I had before. Let's bring that in and let's concentrate on Montana. So we're in State Plane NAT 83, Montana. We know for a fact that that is looking at the state of Montana, so that is a correct projection of Montana. This is what the state is supposed to look like. Your handout is going to make you harp on the cities, and we can do this measurement between Weibo's way over here and Nizzle's way over here and see slight differences, but in the interest of time, I'm going to skip that because it's the exact same thing we just did with the world cities, and we're just going to go right into the next step. Please bring in your streams file, Montana streams, and overlay that on top of Montana. So I want that above Montana in your table of contents. When you get that into your map, I would like for you to make a copy of that in our catalog. So what you need to do is open Mark Catalog, right-click on Montana Streams, say copy, scroll up to whatever folder you're in, right-click, and say paste. I would like to have a copy of that in your folder. This is always a good practice if you're unsure if you're doing project or define project. If you don't know, save your original data. Because it's really easy to mix up in the beginning, whether you're projecting your files or you're defining the projection on your files. So if there's any doubt, save the original. That way, if you screw it up, you can go back to the original and do it right. Whereas if you don't save that original, you can't go backwards. You can't switch back and forth. Well, you can, but it's way more complex. So obviously, this has the general shape of Montana, but it's not falling into place. It's not falling on Montana. These are supposed to be streams in Montana. They're not in Montana. So the projection on this is incorrect. I downloaded this from the web and it said the projection was in NAD 1983. And I know it's a projection. It's a projected file. What's the coordinate system on the Montana streams? Come on. Yes, but that's that. Okay, there are two NAD 1983s that are projected files. One is feet and one is meters. My best guess looking at this, knowing that this is approximately 1/9 the size of the overall map. Remember, we're talking feet to meters here. So it's approximately 1/9. Chances are I put this in feet when it should have been in meters. So in this case, I do not want to project this file because the way it's projecting right now is incorrect. This is the same thing that you did when I gave you a file that said there was an unknown coordinate system and we assigned it in our catalog. This is the exact same tool. Define projection. So let's define the projection on this one. Montana streams, it's in state plane international feet. Let's put it in state plane meters. Collapse that folder international feet and go down one, state plane international meters, and just find Montana. Say okay. Now, indication that it will run the tool, but there's probably something wrong. This little yellow triangle with an exclamation mark in it. Click on that and it'll tell you what that error is. The data set already has a projection defined. That's because, more commonly than not, when you're going to use this tool, it's because it does not have a coordinate system. Not because somebody assigned it inaccurately. Almost certainly you, or me in this case. It's warning you, I'll do this, but be aware it's already got a coordinate system. So we can ignore that because we know that. We know it's already got a coordinate system. It just happens to be the wrong one. Say okay and run that tool. It happened really fast on mine, so I didn't get to show you, but the little check boxes will be grayed out with a lock. It'll freeze your screen and tell you you can't do anything else with these two files while that tool is running. But I know, in this case, I guess which coordinate system it was accurately because it jumped right to where it was supposed to be. So I had put it originally in the wrong coordinate system. I had assigned that incorrectly. I'd like to show you what happens if you use the wrong tool. Did you have a question? Oh, sorry. So bring in that copy that you had of the Montana streams. Bring that back in. It should end up where it started, down in the bottom left corner. This time, project this into NAD 1983 state plane meters. Don't use define project, project it. And for those of you who weren't here previously, when you find a coordinate system that you're probably going to use over and over and over again, NAD 1983 international feet and meters, you can highlight that coordinate system, and then this little star up here, if you click on that little star when that's highlighted, it will add it to your favorites so that it shows up here in your favorites. And then you don't have to go hunt for it every time. It is good practice for a while to find these so that you know where they are, but you can also search for them if you know what you're looking for. You can type state plane or something and it'll take you to it, but you're going to get the whole list of state plane. Okay, all right, so I'm going to uncheck that copy so I'm not looking at it. My copy, I'm actually going to remove it entirely from the map. It's not even there anymore. I projected my copy that was incorrectly done into the right coordinate system, but I did not have it change the coordinates to go with that. So it stayed where it was. Project was the wrong tool to use to fix this. Define project was the right tool because the coordinates were correct in the coordinate system it was in. I just needed to change the coordinate system it was in. Okay, Does this make sense? You guys following this? I'm only harping on this because previous classes have had trouble with the distinction. So I'm kind of overdoing it here. I'm not trying to be insulting. I'm just, from past experience, this is not an easy one to pick up. All right. Okay, so let's remove that from our map. We don't want that in there. And let's look at rasters. The same thing applies to rasters. I'm going to bring in the two rasters, Butte North and Butte South. These should be familiar. All right, I had to go to Worldview to get Butte South to show up. But so here's Butte North showing up where it's supposed to, somewhere around Silver County. But Butte North is in UTM Zone 12 North. And in the interest of good practice, I want this to be in state plane NAD 83 international feet. So I need to do what? Project or define project? Anybody? It's in the right place. I want to put it in a different coordinate system, so I need it to calculate new coordinates. Define projection or project? Project. So in Art Catalog, instead of going straight down to project in projections and transformations, expand that little raster box. And now we've got project raster. So this is Butte North, not Butte South. Project Butte North into NAD 1983 international feet. Bad practice here. I'm leaving mine into my default geodatabase. Put it somewhere you're going to find it. Pay attention to that because, oh boy, if you go up on my computer upstairs where I regularly work in GIS, my default geodatabase probably has hundreds of thousands of files in it. And I guarantee you every time I did that, I didn't know where it went and I wasn't paying attention and I had to run this again because I wasn't paying attention and I don't know where the hell that is. Don't dump crap in your default geodatabase. Just bad form. And you can say okay when you've got that. Notice down here at the bottom, this tool is running long enough to actually see it. It tells me here that it's working on running the file right up until it finishes and gives me the little blue box. It'll tell me across the bottom, project, 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 iteratively until it's finished. If it doesn't automatically pop into your map, wherever you put it, you can go grab it and bring it in. But because I used project, it stayed right there. It's in the exact same place as the original file. Project left it in the right place, but it changed the coordinates. Now let's look at Butte South. What coordinate system is Butte South in? Yes, right coordinate system, NAD 1983, wrong units, meters, wrong state, Wyoming. What do we do? Define project or project? define. So there is no define project raster here. We have done this before. On Butte South, right click, properties. This is the same as define project. Editing the spatial reference is define project. Exact same tool. You can do this with shapefiles or with rasters. This is where we want to change that coordinate system. Edit. Instead of Wyoming, I can't remember if this was feet or meters, so I'm going to assume I didn't change the units too. So just find Montana in this list and keep it in meters. We'll see if that works. Say apply, okay. It may not jump on your screen, but if you hit refresh, it should. Refresh just tells it to redraw it with that new piece of information. So it was actually in meters, it wasn't in feet. In this case, we needed to define the projection. If we're going to take it a step further to put it in state plane international feet, we need to now project it to put it in feet instead of meters. Making sense?
That's the right way.
And wait, close that for 1 second. So click on that space again, watch your help. See how it says if you don't give it, scroll down to this list, if you don't give it extensions, no extensions, it has no grid. You can do this, but it frequently causes problems. If you don't from the adopted to the grids, you're asking to not only change projection, change file type. I tend to try and stay in the same file type. So put a .ti extension. Keep it in the same coordinates or in the same file type. If we want to go into okay. I suspect strongly asking that you have visual strategy crash. That's just because every grid is for every default. So if you don't do that extension, then it doesn't know that you want it to be in the same pattern. I'm going to just
So I'm sorry, I just been doing
I
this
think you just gotta
this
drag
many
one.
times.
Drag one.
we have done this before. That's the exact same thing. So again, so stay in this one because I didn't change the meters. This is meters. Just scroll back down.
Yeah.
So now if you wanted to put it in, you would do this and take the additional stuff and project it. Okay, and if it does not jump on your, it does not jump on your map. It isn't on your map because it didn't redraw. So don't do it. You refresh your map. Left over is
She waited till you first. Sweet.
okay, I'm going to show you guys something real quick because this is probably going to happen to more than one person. I want to project my raster. I pick a raster, Butte North, let's say. Notice up here, it has an extension .tif. When I project this into another to create something else, say Butte North 1, if I don't change that, if I just give it that name, it says no extension creates a different type of file. It's not a TIFF that I started from. It's going to create an Esri grid. This is just generally good practice because sometimes this will crash your tool. Stick with the same file type going in and going out. If you're going in with a TIFF, go out with a TIFF. Put that little extension on there because Esri doesn't like doing more than one thing with the tool. It likes to do one thing, change the projection. It doesn't like to change the projection and change the file type. It's likely to crash you. So pay attention to that. File in as TIFF, file out as TIFF. It should run cleanly. All right. I was going to do one more thing, but we're out of time. So we'll do the dissolve next class. That was supposed to be just a fun little new tool that's really simple to run, but we're out of time. So we'll just pick this up on Monday and do that one. Pay attention to your homework. This is what Montana's supposed to look like, right? Okay, this is how Montana's supposed to be shaped, not like this. That is on your homework. Notice it. Okay? All right, have a good night. Brandon, you had a question, right?
I figured it out.
Oh, good,
I was
okay.
taking a picture of the wrong file.
Oh, okay, perfect. Good. I'm glad you figured it out. Troubleshooting on your own is big. Yep, I have seen these. You got me on here? Nope, okay. All right, there you go.
Thank you.
You're welcome.
Sometime this weekend. I think I should be able to do no problem. But
Okay.
if there are any questions, I'll let you know.
Okay, I'm around this weekend as far as I might be ice fishing on Saturday, so my service is going to be spotty, but I will try to answer it. Did you follow this okay?
Yeah, I actually didn't get lost.
Good. Then you should be okay because this is by far the most complex thing we've done so far.
Yeah,
I was like, well,
I played around with some software, so I just kind of like know.
That's going to give you a
I've
huge
been
leg
doing it
up.
since I was a kid, so I
Yeah,
know where
it's
to.
going to give you a huge leg up.
Yeah, I think I should be fine, but if I have any problems, I'll email you.
Yeah, text me. If I don't get back to you right away on Saturday, it's because I'm ice fishing and I didn't get it. Sorry.
oh yeah,
Have a nice night.
You too.
she's on the,
Oh,
she's gonna want some sweet.
yeah.
soup. And I can get myself on it.
Stop you.
Is that a quick